Hello, in this lecture we will find the radius of a circle enclosed in a triangle. We have a triangle ABC with side AB that equals to 4 units, side BC of the triangle equals to 3 units, and side AC of the triangle ABC equals to 5 units. And we know that the area of triangle ABC equals to 6 units squared. And we want to find the radius of this circle. Okay, first of all, let's define the center of this circle as O. So point O is the center of this circle. Then the touching point between side AB of the triangle and the circle will be defined as N, or the side AB of the triangle is tangent to the circle at point N, and let's define the touching point between side BC of the triangle and the circle as point M, as M. So side BC of triangle ABC is tangent to the circle at point M, and also let's define the touching point between side AC of the triangle and the circle as P. Again, side AC of the triangle is tangent to the circle at point P, and actually we will connect together by a straight line points O and N. So actually line segment NO is the radius of this circle, because it starts from the center of the circle and ends at point N, that is a point on the circle itself. And the definition of radius is any line segment in the circle that starts from the center of the circle and ends at any point on the circle itself is defined as the radius. So line segment NO is the radius of this circle. I will mark it as small r. And we will connect together points O and M by a straight line. So line segment MO is the radius of this circle, because it starts from the center of the circle and ends at point M, that is a point on the circle itself. So I will mark it as small r. That is the radius of this circle, and we will connect together points O and P by a straight line. And actually line segment OP is also the radius of this circle, because it starts from the center of the circle and ends at point P, that is also a point on the circle itself. For that reason, line segment OP is the radius of this circle, so I will mark it a small r. So we actually have drawn 3 radiuses of this circle, and we also have 3 tangents to those 3 radiuses. Side AB of the triangle is tangent to the radius at point N. Side BC of the triangle is tangent to the circle at point M, and side AC of the triangle is tangent to the circle at point P. And also side AC of the triangle is tangent to the radius at point P. Side BC of the triangle is tangent to the radius at point M, and side AB of the triangle is tangent to the radius at point N. Okay, and we actually have a rule. I will call it rule number 1. So actually, rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, I will read rule number 1 again. So actually, rule number 1 states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. So we actually can implement this rule in our circle, because we have line segment NO, that is the radius of this circle, and we have tangent to that radius, that is side AB of the triangle is tangent to the radius at point N. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay? And also line segment OM, that is the radius of this circle, we have the radius and we have tangent BC, we have line segment BC that is tangent to this radius. For that reason, according to rule number 1, this radius is perpendicular to the tangent, that is to say angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees, because the radius is perpendicular to its tangent. So for that reason this angle is 90 degrees, and also this angle equals to 90 degrees. And in the same way we can say that line segment OP, that is the radius of this circle, we have the radius OP of the circle, and we have the tangent to this radius, that is side AC of the triangle. So according to rule number 1, the radius is perpendicular to its tangent, that is to say angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees, because the radius is tangent to is perpendicular to its tangent AC. Okay, so for that reason this angle is 90 degrees, and also this angle equals to 90 degrees. Okay, so in the next step we will connect together points O and B by a straight line. And we will connect together also points O and C by a straight line. And we will connect together points O and A by a straight line. Actually, the general formula for the area of any triangle is actually equals to the base of the triangle times the height to the base divided by 2. So that is the area of any triangle, the formula for the area of any triangle. Again, the formula for the area of any triangle equals to the base of the triangle times the height to the base of the triangle times the height to the base, divided by 2, equals to the area of any triangle. Okay, or instead of the area of a triangle, we can write the capital letter A, abbreviation for the area of a triangle, equals to the base of the triangle times the height to the base divided by 2. That is the formula for the area of any triangle. The base times the height to the base divided by 2 equals to the area of any triangle. Actually, we can implement this rule in order to find out the area of triangle BOC. So the area of triangle BOC, or the area of the green triangle BOC, will be equal, according to the formula for the area of a triangle, the area of the green triangle POC will be equal to the base of the triangle, that is 3 units. It is given us in the question. The base times the height to the base. The height always creates 90 degrees with the base, and as you can see in the drawing, the radius creates 90 degrees with the base. For that reason, the height of the triangle, the green triangle, equals to the radius. So it is 3 times the radius divided by 2. Okay? So the area of the green triangle equals to the base, that is 3 units, times the height, that is the radius of the triangle, divided by 2, or 3 over 2 times the radius. 3 over 2 is 1.5, so I will write it down. So actually, the area of the green triangle equals to 1.5 times the radius of the circle. Okay, the area of the green triangle equals to 1.5 times the radius of the circle. And in the same way, we can find out the area of triangle AOC. So the area of the yellow triangle AOC equals to the base of the triangle, that is 5 units. It is given us in the question, times the height to the base. The height always creates 90 degrees with the base, and in this drawing you can see that the radius creates 90 degrees with the base. For that reason, the radius is the height of the yellow triangle, so it is 5 times the radius divided by 2. Or the area of the yellow triangle equals to 5 over 2 times the radius. 5 over 2 is 2.5, so I write it down. So actually, the area of the yellow triangle equals to 2.5 times the radius of the circle. Okay, the area of the yellow circle equals to 2.5 times the radius of the circle. And in the same way, we can find out the area of triangle AOB. Actually, the area of the orange triangle AOB the area of the orange triangle A or B will be equal to the base of the orange triangle that equals to 4 units. It is given us in the question. 4 units times the height. The height creates 90 degrees with the base, so the radius creates 90 degrees with the base, so it is the radius. The height is the radius. The height of the orange triangle is the radius. So it is 4 times the radius divided by 2. Or the area of the orange triangle equals to 4 times the radius divided by 2. 4 over 2 times the radius. 4 over 2 is 2, so I will write it down. So in total we got that the area of the orange triangle equals to 2 times the radius. Okay, so the area of the orange triangle equals to 2 times the radius of the circle. So we can summarize and say that the area of the green triangle equals to 1.5 times the radius. The area of the yellow triangle equals to 2.5 times the radius, and the area of the orange triangle equals to 2 times the radius of the circle. Okay, but as you can see from the drawing, the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. So we can create equation number 1 that states that the area of triangle ABC, the big triangle, equals to the area of the green triangle, and the area of the green triangle equals to 2.5 times the radius, plus the area of the yellow triangle. The area of the yellow triangle equals to 2.5 times the radius, plus the area of the orange triangle that equals to 2 times the radius of the circle. So in total we got the first equation that states that the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle, because triangle ABC contains those 3 triangles: the yellow triangle, the green triangle, and the orange triangle. So the sum of the sum of the areas of those triangles equals to the area of the big triangle ABC. Okay, we can summarize this side of the equation. 1.5 times the radius to 2 plus 2.5 times the radius equals to 4 times the radius, and 4 times the radius plus 2 times the radius equals to 6 times the radius. So the sum of this side of the equation is 6 times the radius. So I write it down. So the area of the big triangle ABC equals to 6 times the radius. Okay, the area of the big triangle ABC equals to 6 times the radius. 6 times the radius is the sum of this side of the equation. Okay, 2.5 plus 1.5 plus 2.5 plus 2 equals in total to 6 times the radius. Okay, so the area of triangle ABC equals to 6 times the radius of the circle. But we have already know that the area of triangle ABC equals to 6 units squared. Okay, so actually we can substitute the area of triangle ABC by 6, because the area of triangle ABC equals to 6 units square. Okay, so we write it down that the area of triangle ABC equals to 6 units square equals to 6 times the radius. So actually, because of the fact that the area of triangle ABC equals to 6 units square, we can substitute the area of triangle ABC by 6, and we got that 6 equals to 6 times the radius. We can divide equation number 1 by 6. We will get that the radius of the circle equals to 1 unit. Okay, so the answer to the question is that the radius of the circle equals to 1 unit, or the radius of this circle that enclosed in triangle ABC equals to 1 unit. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the circle, this circle that enclosed in triangle ABC. We know that side AB of triangle ABC equals to 4 units, side BC of the triangle equals to 3 units, and side AC of triangle ABC equals to 5 units. And inside the triangle we have a circle, and we want to find out the radius of this circle. Okay, so first of all we defined point O as the center of this circle, and actually side AB of the triangle is tangent to the circle at point N, side BC of the triangle is tangent to the circle at point M, and side AC of the circle, side AC of the triangle is tangent to the circle at point P. We actually connected together points N and O by a straight line. We connected also point O and P, and we connected points O and M by a straight line. Actually, those line segments NO, OP, and OM are the radiuses of this circle because of the fact that they all start from the center of this circle and ends at a point on the circle itself. For that reason, they are defined as the radiuses of this circle, because the definition of the radius of any circle is any line segment inside the circle that starts from the center of the circle and ends at any point on the circle itself. It is defined as the radius of the circle, and those 3 line segments satisfied the definition of a radius. Okay, for that reason, line segment NO, line segment MO, and line segment OP are the radiuses of this circle. Okay, and we also have rule number 1 that states that in any circle, a radius and the tangent to that radius are perpendicular to each other. So if we have a radius R and tangent T, then the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So we can actually implement this rule number 1 in our circle, because in our circle we have 3 radiuses and 3 tangent to these radiuses, and according to rule number 1, the radius is perpendicular to its tangent. So for example, line segment NO, that is the radius of this circle, as the side AB that is tangent to it. Side AB is tangent to this radius. So according to rule number 1, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. And in the same way, we can say that line segment MO, that is the radius of this circle, has also side BC that is tangent to it. And according to rule number 1, the radius is perpendicular to its tangent, PC. So actually angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees, because the radius is perpendicular to its tangent. For that reason, this angle is 90 degrees, and this angle is also 90 degrees. And in the same way, we can say that line segment that is the radius of this circle has its tangent, that is AC. AC is tangent to this radius. For that reason, according to rule number 1, angle OPA equals to 90 degrees, and also angle OPC equals to 90 degrees. Okay? And in the next step, we connected together points O and B by a straight line. We also connected point O and C by a straight line, and we connected also points O and A by a straight line. And we have the formula for the area of any triangle equals to the base of the triangle times the height to the base divided by 2. And you should remember that the height to the base always creates 90 degrees with the base. Okay, so the abbreviation for the area of a triangle is capital A. A equals to the base times the height to the base divided by 2. We can implement this formula in order to find out the area of the green triangle, triangle BOC. Actually, the area of the green triangle equals to the base of the triangle, that is 3 units, times the height to the base. The height creates 90 degrees with the base, and the radius creates 90 degrees with the base BC. For that reason, the radius is the height of the green triangle. So the area of the green triangle equals to 3 times the radius divided by 2. 3 over 2 is 1.5, so the area of the green triangle equals to 1.5 times the radius of the circle. And in the same way, we calculated the area of the yellow triangle. The area of the yellow triangle equals to the base of the triangle, that is 5 units. It is given us in the question, times the radius times the height to the base. The radius creates 90 degrees with the base. For that reason, the radius is the height of the yellow triangle. So the area of the yellow triangle equals to the base, that is 5 units, times the height, that is the radius, divided by 2. So in total, the area of the yellow triangle equals to the base, that is 5, times the radius, times the height, that is the radius, divided by 2. 5 over 2 is 2.5, so in total the area of the yellow triangle equals to 2.5 times the radius of the circle. And in the same way, we calculated the area of the orange triangle. The area of the orange triangle equals to the base of the triangle, that is actually 4 units. It is given us in the question. The base times the height to the base. The height is the radius of this circle, because the radius creates 90 degrees with the base. So the area of the orange triangle equals to the base, that is 4 units, times the height, that is the radius, all divided by 2. Okay, so the area of the orange triangle equals to the base, that is 4 units, times the height, that is the radius, all divided by 2. 4 over 2 equals to 2, so the area of the orange triangle equals to 2 times the radius of the circle. Okay, so we can summarize and say that the area of the green triangle equals to 1.5 times the radius. The area of the yellow triangle equals to 2.5 times the radius, and the area of the orange triangle equals to 2 times the radius of the circle. Okay, but we can say that the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. So we can create equation number 1 that states that the area of triangle, the big triangle ABC equals to the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is actually 2.5 times the radius, plus the area of the orange triangle, that is 2 times the radius of the circle. Okay, so the area of the big triangle ABC equals to the sum of the areas of those 3 triangles, and the sum of this side of the equation is 6 times the radius. So 6 times the radius equals to the area of triangle ABC. But we know from the question, it is given us in the question that the area of triangle ABC equals to 6 units squared. So we can substitute the area of triangle ABC by 6 because the area equals to 6 units squared. So we substituted the area of triangle ABC by 6. We got that 6 equals to 6 times the radius. We can divide this equation number 1 by 6, and we got that the area of the radius of the circle of our circle equals to 1 unit, or the radius of this circle that enclosed the triangle ABC equals to 1 unit. Okay, thank you very much.